All right. Okay, so good morning, everyone. So the subject is hematology, and the subject code is 21 MSH 713, and you are master student semester 3. And so let me show you the syllabus of your hematology. So in the hematology, we have 3 units. So in the unit 1, it has all about 1 second. This online things are really making things complicated. Okay. So in hematology, the first unit is all about bleeding disorders. Then unit 2, we have transfusion medicine, and the unit 3, we have coagulation disorders. Okay, I think basic hematology, coagulation disorders again, hemophilia. Okay, so they given the special diseases in the chapter 3. Then in the unit 2, they have given immunohematology. Then in the unit 3, they have given automation in hematology. So immunohematology, coagulation disorders, bleeding disorders, transfusion medicine, and okay. So this is all about the syllabus, students. We need not to worry. We can cover everything in this. So first and foremost, I would like to know few points about the functions of blood. Can anyone say what is blood, students? What are the functions of blood? I need at least 20 points regarding the functions of blood. Okay. So today I will be somewhat fast because everything is basics. Then I will introduce some important domain specific related things which are related to MSc. Okay. So first, let me have a quick session on functions of blood. So I need at least 20 points. Okay. So let me share my computer screen with you so that I can able to type. Okay. Oh, okay. Can you able to see my screen, students? Can you see what I'm typing? Can you see what I'm typing here? Is it visible?
Yes, sir. We can see.
Yes, very good. Okay, then we can start. Okay, so can you tell me some functions of blood, students? I need at least 20 points. So crank it up. Everyone, it should be a brainstorm. Yes. What is the basic functions of blood? Okay. First one is very simple, to carry
Oxygen
very good
from lungs to.
very good, and carbon dioxide. Okay. Next, other function, quick. I have very less time. Apart from carrying oxygen and carbon dioxide, is there any other functions of blood?
Yes, sir. It carry WBC, platelets.
Okay, it carry WBC. Okay, like protective function. So protective function by
Yes,
WBC. So it
and
can able to kill fungus, bacteria, microbes.
platelets are for the clotting of blood.
Very good.
For the clotting of any wound or something.
Okay, we can say coagulation of blood. Coagulation of blood. To be precise, very good. What is your name, student?
Jaskaran Singh.
Jaskaran, very good, Jaskaran. This particular function of blood, we can say it as a hemostatic mechanism. Hemostatic mechanism. You know what is this hemostatic mechanism? Hemostatic mechanism is hemostasis, to stop the bleeding. So blood has a mechanism of prevention of bleeding. Only if there is a cut, only if there is any cut or wound on the surface of skin, then the blood can able to clot itself. But the real interesting thing is the ingredients that are required to clot the blood, they are already present in the blood, but they won't get activated if the blood is inside the body. Only if the blood come outside the body, then they will get activated and they will clot the blood, which is really interesting and fascinating mechanism. We have intrinsic, extrinsic, platelets involvement, their factors involvement, cytokines. So everything played together to prevent the blood. So blood has its own mechanism of controlling its state. Okay, so it will be in fluid state in the body. If it come outside the body, it can become a semi-solid to solid state. Okay, upon clotting. So that is a really interesting function of blood. Very good, Jaskaran. Next, what are the other functions of blood? Other functions apart from these three: carrying oxygen, protective function, platelets for a hemostatic mechanism. Then blood also plays a vital role in nutrition, transport of nutrients. Okay, so transport of nutrients by the blood. So whatever nutrients we are thinking, all of them are transmitted to the tissues, are transported to the tissues by the blood, right? Blood is the common medium for the transport of all nutrients. It can be albumin, it can be carbo, it can be proteins, it can be lipids, everything. Okay, Everything is transported by the blood. So that is one function of the blood. Next, what are the other functions of blood? Transport function. Then, okay, we have transported something to the tissue. Okay, say for example, we transport glucose to the tissue, then the tissue utilize the glucose, then it underwent glucolysis, then Krebs cycle, HMP, this electron transportation. At last, the waste products of glucose metabolism. So the waste products will be excreted in the blood also, right? So blood not only providing transport to the nutrition, but blood also plays a vital role in excreting function of the blood, okay, of metabolic waste products. Metabolic waste products will be excreted by the blood. So that is one function of the blood. Any other functions of blood apart from this 5? Oxygen,
maintaining pH of the body.
Excellent point, Jaskaran. Yes, maintaining blood pH. So maintaining pH is one important function of blood, and this particular action is called as buffering. Blood acts as a very good buffer to maintain the pH. And can anyone say the ideal pH of blood? So it is around 7.32 to 7.42 will be the normal pH of blood. Now, the pH is very vital for the normal functioning of body. I will tell you the reason. Okay, the reason why the pH is plays a vital role. Now, listen, students. All the enzymes in the body, the factor that is vital for normal enzymal activity is their pH. Each enzyme has its own specific range of pH for its normal functioning. Say, for example, trypsin, hexokinases, all these digestive enzymes requires acidic pH, which is around 1 to 3. Okay, acidic pH is required for some enzymes required alkaline pH. Okay, now okay, all these enzymes can function if the blood pH is in the range of 7.32 to 7.42. If blood pH alters beyond 42 or less than 32, then all the enzymes will shut down. You just alter blood pH to 6 and the patient will die immediately. Spontaneously, the patient will die if you alter the blood pH. So maintaining the pH is very important. The life, the vitality of the life is critically dependent on the blood pH. If blood pH altered, means game over, the patient will die. So maintaining blood pH is one of the important function which is maintained by the blood itself. So this is achieved with the help of bicarbonate buffer system. So we have some bicarbonate molecules, carbonic acid and bicarbonic acid, bicarbonate molecules, and they will play an important role in maintaining the pH of the blood. So yes, that is one important point, function. Then any other functions of blood apart from this 6? pH. Quick, students, I don't have time. Any other functions? Yeah, I will tell you. The other function is maintaining the body temperature. Okay, body temperature is maintained with the help of blood. Okay, blood won't maintain body temperature directly. The primary organ that is responsible for heat generation in the body is liver, because liver is the site where there is the major amount of metabolic activity will take place. Okay, the higher the metabolic activity, one of the byproduct of metabolism is heat generation. And so since there is high metabolic rate in the liver, so liver is the primary source for generation of heat. Okay, now the heat that is generated by the liver, this heat will be distributed throughout the body with the help of blood. Blood will act as a good conductor to distribute heat within the body. Okay, that is one important function of the blood. Maintaining even body temperature. I'm telling again, maintaining even body temperature is achieved with the help of blood. Any other functions of blood, students? Okay, see, students, any fluids in movement will generate pressure. Keep in mind, liquids in flow will generate pressure. Okay, liquids in flow of any tubes will generate pressure. Okay, the obviously for movement of any liquids, we require a high pressure area and a low pressure area. The fluids can only move from high pressure area to the low pressure area. Okay, say for and this pressure variations is given by heart, obviously, but upon giving the pressures, the flow of without presence of blood, we cannot maintain the blood pressure. And why does the blood pressure important to the body? See, we need to push the blood up to around 70 kilometers lengthy blood vessels in the body. Even if we consider the tiniest capillaries in the body, if we stretch all the blood vessels which are present in the body, then these blood vessels can go up to the extent of moon. We can reach moon with the help of our blood vessels if we knot them side by side. That is the level of drainage system we have in the body. Okay, I can say blood vessels like a drainage system. So in order to push blood, in order to flow the blood in all this complicated drainage system, obviously it must need some high pressure. So without pressure, blood cannot reach to the tips of the extremities of the body organs. So a drop in the blood pressure will decrease the amount of blood going to the vital organs, and there is a chance of organ failure because of lack of blood and lack of oxygen, where the organs will go ischemia and they will go to hypoxia and they will die because of lack of oxygen. So all this blood flow can be maintained with the help of blood pressure. So blood pressure is one function of blood. Without blood, we won't get blood pressure. Okay, so blood pressure is one function of blood. In case of hypovolemia, that means decreased blood volume in the body, then there will be alterations in the blood pressure, and there is a high chance of patient that due to hypovolemic shock, which is induced by the heart. The heart will block its functioning because of it won't get that reload of blood. Okay, I will give best example of blood pressure regarding the heart. You know, right, motor pumps, the water pumps that we have outside. So sometimes if the pump is not able to get the water, then we will pour some water into the motor pump. After pouring some water, the pump will start, pumping the water outside. That means it needs a certain volume of fluid that need to be present in the chambers to start the reaction, to start the pumping mechanism. Okay, yeah. So there is some interesting physics going on within the heart. Anyway, in a nutshell, blood pressure is very important for normal functioning of a body. So that is one function of the blood. Any other functions of blood? So far we got 8 points. Still we can crank many points. Okay, so try to get more functions. Can you tell me any other functions of blood? Yes, students? Can you tell me? Okay, urine formation. Okay, urine formation. So urine formation is very important because the body can truly excrete something either by urine or by digestive tract, either by excreta, okay, by digestive system. So urine is the primary source of excretion of all metabolic waste, electrolytes, and other harmful neutralized toxins and poisons will be excreted by the urine. Okay, drug metabolic waste products or any metabolic waste products are truly excreted by the urine, and urine formation is extensively taken place in the kidney, which is due to filtration of blood. So without blood, we won't get urine. Without urine, we can't excrete toxic products. Without excreting them, we will die instantaneously or eventually. So that's why urine formation is also one important function of the blood. Any other indirect functions of blood like this? Can you tell me?
The growth of hairs of body.
Growth of hair of, okay, very good. Yeah, yes. In your words, I will tell that is long-term growth of anything. Long-term growth of anything is facilitated by blood by the presence of hormones. Okay, so hormones will indirectly help us to have a chronic growth development in the body, like a development of bones, development of hair, nails, all your body organs. Okay, so that long-term growth facilitated by with the help of hormones. Obviously, hormones are suspended in the blood. So that is one function of blood. Very good, Just Karan. Any other functions of blood?
So formation of sperm.
Okay, formation of, we are going to the level of organ specific functions. No need. In a generalized point, it will facilitate. Okay, blood will facilitate normal function of all body organs. This will be the simplest definition for you. Okay, yeah. Any other function of body? We need more. I need more. Okay. It sounds somewhat awkward, students, but I want to tell, without blood, the lungs can't function, because see, okay, lungs are functioning, but we don't have blood, so our organs cannot get their oxygen. Okay, so the hemoglobin plays a vital role. Okay, this will be carry of oxygen, carbon dioxide only. Okay, indirectly, blood maintaining normal function of lungs not required. Any other function, students? I'm not satisfied. I need more. Any other interesting points about blood? Okay, I need from you. Any one more point for my satisfaction? Yes, just Karan. Even I to run out of points. Any interesting function of blood apart from this? Neutralizing of toxins, we can say, but okay, students, this is fine. So anyway, you did great at generating almost 11 points of blood. Okay, so to carry oxygen, protective function, prevention of bleeding, nutrients, excreting function, then yes, your voice broke down.
Maintain homeostasis.
Very good. Maintain homeostasis. Damini, right? Yes, Damini. Yeah. There is a difference between homeostasis and hemostasis. Very good. So homeostasis means keeping the body in its optimal conditions is called homeostasis. Okay. Keeping the organs in their functional status is called homeostasis. So homeostasis is ultimately maintained by blood only. Okay, the body is stabilized because of blood. Okay, so blood plays a vital role. Very good, Damini. So this satisfied my 12 points. So homeostasis is extensively dependent on this blood only. So blood plays a vital role in homeostasis. By the way, since you said homeostasis, I want to tell a small definition of disease. Okay, can anyone say what is the meaning of disease, students? D-I-S-E-A-S-E. What is disease? Can you define it, anyone, for me? Can anyone define what is disease? When we will say someone has a disease, can you tell me what is disease? So my point is, alterations in homeostasis results in disease. Now tell me what is disease in your definitions. Okay. Okay. Now I will, or else I will give you even more simple thing. How can you differentiate a healthy person from unhealthy person? Yeah. How to differentiate a unhealthy person from healthy person? Okay. The simplest definition that I can give is an unhealthy person. Okay. A healthy person can able to do his work normally. Okay. But unhealthy person cannot do his okay, he cannot work easily. Okay, it is antonym of easy. Okay, antonym of easy will be okay. I want to tell an English trick. Okay, like, what is the antonym for like? Can anyone say?
Uneasiness.
Yes, uneasiness. For antonym of like, dislike, we can say simply dislike. Okay.
Yes, sir.
Yeah. Similarly, we can work easily if there is a problem with easily body activities. Even if you can't do your normal easy activities like climbing steps, drinking water, eating heavy food, even if you can't do your normal easy activities, then such condition we can tell in English dis. That means against ease. Okay, and that is how the name came. The origin of disease means dis-ease. So we can't work easily. Okay, so yes, disbalance in homeostasis will result in diseased condition. That means now we can't work easily. Okay, this is just the origin of this term. Okay, but there is no direct disease. This explanation in the Oxford Dictionary. So this is, they adopted from Latin and Greek. Okay, that is how this came as a disease name. Okay, antonym of easy is called disease. So most of us don't know about this one. Okay, I too learned about it recently 1 year ago in one YouTube channel. I think Cross Kazakh, very nice channel. Anyway, so that is disease. So diseases occurs due to disbalance in the homeostasis. Usually, how we can able to maintain a normal homeostasis? We can maintain normal homeostasis if our blood is in its functional state. If there is no alterations in the blood, then we can have a good homeostatic function or a very good healthy lifestyle. If there is any problem with the blood, then definitely all these things will alter. We can't carry oxygen, we can't have immune system, we will bleed a lot, we will become starved, we will become toxic, we will die soon, our body temperature will increase, blood pressure will be altered, urine cannot. So all these things will disbalance, eventually leads to death. So by this simplest thing, we can understand the vital role that blood is doing to our body. Even we can say that blood is the fluid of life. Without blood, we can't survive. So blood can be stated as a fluid of life. So this is all about the blood. Now I want properties of blood. Properties of blood. So can you tell me what are the properties of blood? So that
the blood is red in color.
Very good. So properties, first we can write the side headings. Okay. So whenever we are saying properties, we are saying about certain generalized things. So CYLO, your color, then volume.
Viscous or viscous fluid.
Very good. Viscosity. Then what else we need to? pH. pH yes, of blood. Then specific gravity. Any more other properties of blood we can write?
Morphology and morphology of blood.
Very good. Morphology. Very good. Any other properties? Color, volume, viscosity, pH, specific gravity, morphology. Any other we can add to it? Okay, this is fine for me. Okay, what is the normal color of blood? Blue.
Red.
Red. Okay. Okay. What is the reason for being blood in red color? Can you tell me the reason? Due to presence of hemoglobin. Yeah. So why hemoglobin is in red then? Why hemoglobin? I need to mute you all 1 second. Let me mute you all. It's very disturbance. Yes, thank you. Okay. Why blood is in red? Can anyone tell me the reason, students? It is really interesting question. Okay. How many of you seen a rusty nail? We know the nail, right? Keel in Hindi. So nail, this iron nail we will keep to the walls. Okay. Even if we expose this nail to the environment for 1 year, what happens? It will react with oxygen in the environment and it will go oxidation and it will rust. The nail will rust, right? What is the color of rusty nail? It will be brick red to brown in color, right? Brown in color. That means oxidation of iron in the nail resulted in red color. And that is what exactly happening in our blood actually. The oxygen in the blood is reacting with iron present in the hemoglobin. Iron present in the hemoglobin resulting in ferrous state or oxyhemoglobin. So that is why it is in bright red. Okay, so yeah, this is the reason why the blood is red in color. That means we can say safely that blood is constantly rusting and we need that rusting process, that rusting keeping us alive. So whenever you are seeing a rusty nail, don't scold the rusty nail, because the same phenomenon happening in our body, and that is the reason why we are alive today. So rusting is a very good chemical process that is vital for our survival. Okay, so yes, that is what happening in the blood, and that is why the blood is in red color. And one more point we can write, the count of cells in the properties. Okay, It will be a really broad statement, but I'm writing it. What is the normal volume of blood, students? Can you tell me the normal volume?
In a human body,
Yes.
in male, it is 12 to 16.
12 to 16 what? Volume. Okay. Tell me. 12 to 16 what? Liters.
No, sir, I'm not asking about volumes.
Volume.
Total count of HB.
HB. Okay. That we can write a range 12 to 16. Okay. Both males and females together. We can write a range. Grams or milligrams or micrograms or nanometers or deciliters. Yeah. Tell me the unit properly. Most of the students doing wrong here. And your master's.
Gram per year, sir.
ML.
Gram per year.
Very good. Grams per deciliter.
Gram.
Very good. Grams. Never write
Gram
milligrams. Okay. Most of my students in Viva, they will say milligrams.
Yes.
And I used to, nice things for them. Anyway, yeah, volume. What is the normal volume of blood? Normal volume of blood. Quick. 100 liters. 20 liters. So it will be around 4.5 to 5.5 liters. Okay. In an adult, keep in mind. Okay. In a healthy adult. Okay. Then now students, what is the viscosity of blood? How you will justify this statement? How you will explain this statement, students? Blood is viscous fluid. How you will answer this one? Tell me. Viscosity of blood. Tell me how you will tell. Now listen, students. One important thing, blood is not viscous fluid. I'm telling again, blood is not in viscous state. Keep in mind, the only fluid that is in viscous in our body is synovial fluid. Apart from synovial fluid, no other body fluids are viscous. Viscous, if we are terming something as viscous, then definitely we are stating it as a pathological condition. In medicine, viscous is all about disease, some problem. Okay, but why we are telling blood? Here we should compare blood. It is 5 times more viscous than water. Which you should compare it with water. Comparing with water, blood is somewhat looks like viscous, but it is not true viscous fluid. In order to become something viscous, it must need mucopolysaccharides. Thankfully, there is no mucopolysaccharides in the blood. If there is mucopolysaccharides, the harmful effect of mucopolysaccharides is coagulating or becoming semi-solid in in low temperatures. That is why, since there is mucus in the lungs during winters, there is a high chance of bronchospasms and this sputum generation. So blood is 5 times more viscous than water. You need to keep this in mind. Okay. By the way, why it is somewhat viscous compared to water? Because of presence of proteins in the blood, albumin. Because of presence of albumin, blood is slightly viscous. Okay. And what is the normal pH? Normal pH is 7.32 to 7.42. Some textbooks, they will give even range. Okay, 7.34 to 7.44. So it will fall in between 7.3 to 7.4. Okay. Higher is called as I don't know upper arrow how to keep in this keyboard. Anyway, if higher, then that is called acidosis. If it is lower, then it is called alkalosis. Okay. Then specific gravity. Can anyone say the normal specific gravity of blood? And what is specific gravity? Can you define specific gravity, and can you tell me the normal specific gravity of blood? Yes, students. What is the normal specific gravity of blood? It is 1.52. Okay. So specific gravity means number of solutes suspended in a unit volume of fluid. can be stated as a specific gravity. Okay, the higher the molecule suspension, the higher the specific gravity. The lower the suspension. By the way, when I say solutes, always keep in mind these solutes are always electrolytes. It can be sodium or potassium or those ions. Okay, electrolytes will contribute to the specific gravity of the blood. There are some other molecules, but majorly the electrolytes will maintain the specific gravity of the blood. And electrolytes is very important for normal transfer of nutrients among the cell membranes of the body. So cell membranes require this osmotic gradient. Okay, this osmotic gradient can be achieved with the help of maintaining a good specific gravity or molecule suspended in the blood. So that is one important point of property of blood. Then any other properties? What is the morphology of blood? Triangle, circle, rectangle. So it is biconcave. Okay, biconcave in shape. The reason for biconcavity is for increasing surface area. To increase the surface area, the morphology of the red blood cell is biconcave. Then last and final, students, one important thing in biology, whatever cells we are drawing, we need to keep the nucleus. Does the red blood cell has nucleus? Does it has nucleus? Is it a nucleated cell or enucleated cell? It is a enucleated cell. Okay, then if we say blood as a enucleated cell, in biology, as I stated, enucleated cells are always dead cells. Only dead cells can be stated as a enucleated cell. Then can we able to tell red blood cell as a enucleated or dead cell? Is red blood cell is a dead cell? Is RBC a dead cell? Because it don't have nucleus. Okay, for this I will tell you, students, can we able to tell the hair as a dead cell? Can we able to tell the nail as a dead cell? Okay, the nail and hair don't have the vascular supply in one way or other way, they are dead cells. Similarly, the red blood cells are also terminally differentiated cells. Okay, I'm telling the word again, red blood cells are terminally differentiated cells. In their history, in their development, they do have the nucleus, but once they are releasing from the bone marrow into the circulation, they lose their nucleus. Okay, so in this state they can only live for 120 days. In the absence of nucleus, blood only can stay few days in the circulation. That is why the blood lifespan is very less, like 120 days only. Okay, and by the way, why evolution has favored the red blood cells to lose its nucleus? What is the reason for removing nucleus from the cell? The primary reason is for flexibility. If there is nucleus, the cell cannot be flexible. If we remove the nucleus, the cell will become more flexible, because since red blood cells need to travel a very tortuous pathway of this capillaries, so they need to squeeze, they need to push, they need to they should do all gymnastics. So in order to facilitate the squeezing action of the red blood cells, so the evolution favored to remove the nucleus from the red blood cells. By the way, a quick fact, birds, all avians, all birds cells have nucleus. All birds red blood cells has nucleus, and the reason why they have nucleus and the reason why we don't have nucleus is really interesting. You can Google it. Okay, that is one interesting fact about the absence of nucleus in the red blood cell. Then last and final is the count of red blood cells in the body. So the count will be, for one drop, just for one tiny drop of blood, we have almost 5 million cells. Really interesting thing. So my 5 million cells are suspended in a small drop of blood. So this is all about the red blood cell, their properties and their functions. Okay. So in tomorrow's lecture, we can discuss about the branches of blood and hematology. Then we can go to the actual subject, which is really interesting. So any doubts so far, students? Have you listened to today's lecture? Is there any issues with today's lecture? Any doubts? I may raise some interesting questions here and there. So can I end this session, students? Can I end this class? Okay.
Yes, sir.
Yes. Thank you very much, students. Yeah.